Hello everyone, welcome to our channel Code with Sunny, and today we will be discussing the problem related to bit manipulation, and it is the medium type problem of the LeetCode. And you can see over here I have given a like and also have added to my favorite list. Like this problem is going to teach us many concepts. Also, if you are unaware about the trie data structure, then you must have to read it at least once and you need to know how to implement it. Also, we are going to use a hash map to solve this problem efficiently. I'm going to explain the two approaches, and first of all let's build out the concept how we are going to use to solve this problem efficiently within the given time constraints, right? So let's begin. Given an integer array nums, return the maximum result of nums of I XOR bitwise XOR nums of j, where I and j is going to belong in this range and I can be equal to j. Okay, you can see the problem name is like maximum XOR of two numbers in an array, and we have been asked exactly the same thing. We need to choose out two numbers such that if we perform a bitwise XOR of these two numbers, we are going to have some answer, and that answer must be maximized. Okay, so you can see some of the examples over here. I will discuss it out efficiently. And first of all, what I need to do is like I need to explain out the concepts very well, how we are going to do that. Also, you can look over the constraints, like maximum length of the array is like 2 into 10 raised to the power 5. Okay, so we need to find an efficient solution, right? Also, I would recommend you guys that if you're facing some problems related to bit manipulation, then I have a playlist in my channel. You can solve such type of problems and you can be like much more frequent to that. Also, in every bit manipulation problems like related to bits, I would recommend that you should start thinking that what is the maximum number of bit positions there are. That is, you can see over here nums of I is 2 is less than equal to 2 raised to the power 31 minus 1. So there are total 31 bit positions over in this for any maximum number in this array. So you should think that your complexity would be O of n into the maximum bit position, that is 32. So in many of the questions this complexity is going to be used, and the same thing we are going to use in this problem also. Okay, so let's build out the concepts how we are going to do that. So let me just open my open board software and let's begin. Yeah, I think where it is, yeah. So how I will explain it out in that efficiently. Okay, so the very first approach would be like, so you have been given some nums of array. Okay, and this array is max size is 2 into 10 raised to the power 5. So the very first brute force approach would be that would give you a TLE, but still I will explain it out from the scratch. Is be like choosing the two numbers in O of n square time and performing the bitwise XOR will take O of 1 time. So your complexity would be O of n square. You would get a TLA with this approach. Okay, so how would you find two numbers and with their maximum XOR? So let's pick out an example and we will understand how this is going to be done. Like 3, 10, 5, 25 to 8. So the number is 3, 10, 5 and 25 to 8. 25, 2 and followed by 8. Okay, so let me write down the binary representation of all these numbers. Okay, so I will write down one as 1 and 1, and I will write down 10. Let me just write it clearly, 1 and 1. And for the 10 it should be like 8, 4 and followed by 2 and 0. So I will fill out 0 over here also. And for the 5 you can say you are going to write 101 and 0 and 25 you are going to write down 16, 8, 0, 0, 1. So I will append to the beginning all the extra zeros. Okay, so for the 2 you are going to write 1 0 and 0 0 0, and for the 8 you are going to write down yeah, so this should be good. Okay, so these are the binary representation of the given example. So we need to find two numbers, right? That is their maximum would be like the bitwise or its maximum. You can see if you take the bitwise or of 5 and 25, let us calculate this value. You can see 0 0 1 0 1 1 1 0 0 1. So you will get 0 0 1 and again if I'm not wrong 1 1. So what is this value? Its value is like 16 plus 8 plus 4, which will come out to be 28. And you can see this is the maximum one. So, but we are not going to choose this in O fence cut time. Rather, we are going to use an efficient approach. Let's talk about how we are going to build in using the concept of hash map and how we are going to manipulate it. So we are going to use a greedy approach with the help of hash map. So let me write down greedy approach. Okay, so how this greedy approach is going to do? So as we all know that for a given binary representation of k places, let me write down over here. So you can see for the greedy type of thing, you must fill this bit first. You can see it is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So you must start filling with this bit. This is because 2 power 4 is going to be like greater than the sum of all these values, like 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. So the optimal case is to fill this bit first, and it doesn't matter what the values of these either 0 or 1, but you must fill this one first, 2 power 4, that is starting from the highest bit position. Okay, so the greedy approach would be like starting from the highest one, that is if you look at the maximum bit position, it is for 31. Okay, so we'll be starting from the if it is a 0 based position, so we'll be starting from the 30. Okay, so tell me one thing, that starting from the 30, our answer would contain some bit positions up to starting from 30, and it will goes up to 0 bit position, that is total 31 positions. So at the 30th position, so what we need to put either 0 or 1, right? That is, this can contain 1 or this can contain 0, either 1 or 0. So the greedy approach would tell us that first we will need to adjust this position either 1 or 0, but if we fill out the 1, that is at this 30th position, our answer will be incremented by 2 power 30, right? So first we will claim that yes, if we can put out 1 over here, and if we will put out 1 over here, there must exist exactly two numbers in this array whose bitwise XOR we will take. Then the bitwise XOR, after taking that, the value at this position, that is at the 30th position, must be exactly 1. That is, the bit is set at this position. How we are going to check it out for that? Okay, so you can see there are only 5 positions over here, that is, we write it down on 0 based indexing, 0 1 2 3 4. Okay, so I will just start explaining for this 4th position. It doesn't matter if you are starting from the 30th one, but for now the maximum bit position is up to 4. Okay, so first I will explain starting from the 4. So I will explain it down in the general case, so you can start it from the 30. Okay, so using this concept, what I am going to do is like you can see there are how many positions? 0 1 2 3 4, right? It completely matches with that. Now you can see I will claim that at this 4th position, that is 2 power 4, can we make this bit as set at this position or not, right? That is, our answer must contain the bit which is set at this 4th position starting from the rightmost index. If we use a 0 based indexing, you can see. Now I am claiming that in our answer it should be like this one. It doesn't matter what are the positions to this one, but I will claim that yes, if it contains, can we put out the bit which is set at this position or not, that is the value as 1. Okay, so if I will write down this value as 1, so there must exist exactly two numbers. If we perform the bitwise XOR of these two numbers, A XOR B, okay, then the value that we will get, let's call it as answer, then the ith position, that is the 4th position I'm talking about, the bit must be set at this 4th position. Can we have this number in this entire array? Two numbers. Okay, so if you check it out, that you can work on the prefix of each numbers. You can see, let me highlight it. Yeah, this is the prefix. Okay, so just tell me one thing, that can you choose any two numbers? If you perform the bitwise XOR of these two numbers, then the bit must be set at this 4th position. Yes, you can pick 10 and you can pick 25. So if you work on the prefix, you can see 0 XOR 1 must give us the value as 1. So it means that yes, we can pick up two numbers. Okay, so yes, we can pick up two numbers. So I will say yes, we can have a bit as set at this position. Okay, so what I am going to do is like note that we are working on the prefix, because as I've already said, we are working on the prefix because you will say 2 power 4 must be greater than this 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3. Okay, and to make this XOR as maximum, you must start from working from this highest bit position, that is for the fourth position. Okay, so we will start from the fourth position. If you're not getting it, no need to worry, but I know this problem is quite typical. I will try to explain it the best possible way. Okay, so I will write down 1 over here. Now the next thing is what should be the value, the bit should be set or not at this position. It is 4 3 2 1 0. Okay, so our we need to maximize the XOR, right? So we will claim that yes, the bit is set at this position. If I will say that yes, the bit is set at this position, then we need to just find out two numbers in this array. If we perform the bitwise XOR of these two numbers, we will get the prefix as 1 1. We will must get this prefix as 1 1. Okay, so let's find it out if we can have these two numbers. Okay, so the prefix is this one. One doubt that must arise in your mind is like why I'm taking the prefix starting from the most significant bit. Why not to take only this exactly one bit position, that is for the bit positions of 3. Why I'm taking these two, clubbing these two bit positions, that is taking the prefix. The reason is because we have already find out the answer at this bit position, and we must not lose this answer. If you start working on only this bit position, that is exactly this bit position, then we may lose this answer. But we don't want to lose this answer because this will maximize our answer. Okay, because 2 power 4 is always greater than 2 power 3, so we should not lose this answer. Rather than we should maximize it, so we should check it out by clubbing these two positions. Okay, so we're not going to waste time over more this one. So the prefix is going to be sorry, I think let me write down the prefix clearly. It should be like taking the two positions. Okay, okay, so now just tell me that if we have two numbers from these, if we can choose two numbers from these numbers whose prefix, if we perform a bitwise XOR, is going to yield this value 1 1, and it doesn't matter, right, what is over here. We are not going to deal with this. What matters is only this one. Okay, so you can have two number, you can have the prefix as 0 0 0 1 0 0 and 1 1 0 0 and 0 1. Right, so yes, we can choose two numbers. If we can choose this 0 1 and 1 1. Okay, so yeah, can we choose these two numbers? You can see if you perform a bitwise XOR of 0 1, and you can see I am choosing out the prefix, right? So the rest of the bit positions after that must be 0. Okay, so if you perform the bitwise XOR of 0 0 and 1 1, let's check it out. You are going to get 0 and 1. No, you are not going to get this as 1 1. So let's try some another possible value. Yeah, so you are going to pick up this and pick up this. So it should be like 0 0 and 1 1. Can we do perform the bitwise XOR? 1 1. Yeah, we are going to get this, which is matching with this one, right? So yes, we can pick these two numbers. So it means that yes, we can have the bit as set at this position. Okay, because we can choose two numbers whose prefix, if we perform the bitwise XOR, yes, we can get these two numbers. Okay, so it means that yeah, we can get. So let me just erase it out and write down this once again. Okay, so yeah, so we are going to have 1 over here and we are going to have 1 over here. Okay, so let me write down the positions also. 4 3 2 1 0. Now again, so let's claim that can we put out the 1 over here or not. Let's say yes, we can put out the 1 over here, so our answer would become 1 1 1 followed by this 0. It doesn't matter over here, so we will just claim that yes, we can, if we can have this arrangement, then we can say yes, we can extend the positions over there and put out the bit as 1 at this second position. So let's try to club out the first three positions. Okay, so what I'm going to do is like picking this up, and picking this up, and again picking this up, this one and this one. Okay, so let's check it out. If we can choose two numbers and perform the bitwise XOR of these two numbers, then we are going to get the same prefix as this one. Note that I'm talking about prefix and picking up the prefix. Okay, because we need to maximize our answer starting from the most significant bit. Okay, so yes, we can choose this one. Let me just say, yeah, you can choose for this 5 and 25. Let's pick out their prefixes. So it will be 001 and 110. Let's find out the bitwise OR. Note that the rest of the numbers are 0. So it doesn't matter, it will be 00 and it will be 111. You can see, yes, we are going to get the same number as over here. Okay, yes, it means that yes, we can also put out the 1 over here. Okay, so let's put out the 1 and let's complete this problem explanation. Okay, so I will just put out this 1 over here, and now these 2-bit position, let us claim it out and check it out whether we can do this or not. So we are going to put out, let's check, we are going to put out this 1 over here or not. So answer would become 1 1 1 1 and again 0. Okay, so let's check it out whether we can choose any two numbers from over here, like over this one, like over this one, like over this one, this one, this one and this one. Okay, so we have for the all the prefixes as 0001, 0101, 0010 and 0. Yeah, we can okay, so I'm not going to waste our time over this one. So okay, so you need to just check it out whether we can have two numbers whose bitwise OR would give us this exact prefix. So I will not just waste time. So you're not going to find any of the prefixes whose if you perform the bitwise OR will give you this all 1 over these positions. You can check it out. If you can pick up this one or this one and perform the bitwise OR, you're not going to get all the ones over this prefix. Okay, so it means that if you're not going to get any of the two pairs whose bitwise OR is not going to give all the ones over this prefix, it means that the putting 1 over this position is not optimal. Okay, so in that case what I am going to do is, like, I'm not going to put out the 1 over here. I will be just putting out 0 over here. Okay, now again, what would be the value that is the bit should be set or not at this position? Let's claim that bit should be set at this position. Then we'll try to find out the prefix of all these values and we will check it out if we can perform the bitwise XOR of these any two numbers, and if we can get this value, then we are done. Yes, we will put out the 1 over here, otherwise we will not put out the 1 over here. Now everything is done. You are going to say that yes, also for this final case we are not going to find out any two numbers. Now the thing is how to find out the two numbers. Suppose we have some answer as this one and we will I'm claiming that yes, answer can be this one. So now you need to find two prefixes whose bitwise OR will give us this value. Right, how do you find out these two numbers and check it out the pair conditions? It will take off O of n square time if you perform the brute force approach. So if you are going to use the concept of bitwise XOR, you are going to do this in O of one time or O of n log n time. Yes, if you use a set, then set int, so you will get a O of n log n time. But if you use an unordered set, then you will get a O of 1 time, which is average one. Okay, so what I'm trying to explain is, like, suppose you are going to have two numbers A or B, and this will give you this answer, right? This answer. So how do you find that yes, there exist two numbers whose bitwise XOR will give us this value? So you will use the XOR concept. Let's perform the bitwise XOR with the number B over LHS and RHS. So you will get A XOR B, XOR B exactly equal to answer XOR B. If you will do that, then you are going to get this B XOR B will be 0. So A XOR 0 will be A exactly equal to answer XOR B. Okay, so if you will fix up this value, not saying at this one, if you fix up this B value and you will perform the bitwise XOR A answer XOR B, and you will try to check out whether this value is going to exist in our array or not. You can do this efficiently with the help of set. If it exists, yes, we are going to have these two numbers, right? So this is the entire approach. So let's talk about how we can use this one in the coding part, you can see I have the different runtimes. So the first one was I've used the trie data structure, that why it takes a lot of time, but finally I've been successful in using the unordered set concept. And okay, so let's begin. So unordered set int prefix, and we have the max XOR and we have the mask. Okay, mask is used to extract the prefix. You can see extract all prefix bits from 30 with the help of mask. Okay, so how we are going to extract it? It is a very simple concept. You are going to use the bitwise AND operator, and the mask is going to put out the 111 over here. Okay, so if I can do this efficiently, is like, suppose you want to extract the bit of 10101 and we have 0. Suppose you want to extract these three positions. So what you are going to do is you will put out 1 and the rest of the would be 0, and you will perform the bitwise AND. Note that AND, bitwise AND. So you will get this 101. That is exactly the same arrangement for these three positions. Okay. Now, okay, so each time what I'm going to do is I'm going to insert all those prefixes in a set that will help to search for any prefix efficiently. You can see prefix dot insert num and mask. That is for each prefix of this number up to the current bit position starting from 30. Now let's check it out whether we can find two numbers whose bitwise XOR of their prefix will be exactly equal to the new XOR. Note that new XOR is like claiming that at the ith bit position we can have this 1 or not. Note that I'm appending, that making the bit as set at this ith bit position by making the max XOR found till now and performing the bitwise OR with this 2 power I. So let's iterate over here and let's check it out whether we can find out the two numbers or not. Note that I have used the same concept, A XOR B and answer. You can see I have used new XOR, that is the new answer, XOR the prefix, that is the current number. You can see answer XOR B, and if that exists in the set, which is A actually, if that exists in our array, yes, we have already found the found as true. So we can put out, you can make the bit as set at this position in our answer, that is the max XOR. So I will assign max XOR as new XOR and we will return the new XOR. Okay, so finally I will be also attaching my trie solution over here in the description section of the video, which is also a good one, because also you are not going to find out any problem in understanding this code, because I have written in so neat and clean way. You can see there are trie node and trie data structure, and this is insert function, and this is the get max XOR, and I have written the code in the most efficient way. You can see demand bit and the bit that is at this current position, that will help you in understanding the efficiently. So the trie data structure has the complexity of O of n into the max bit position n into 31, and also for this case with the help of HashMap, the time complexity would be like in worst case it can go bad, but unordered set has an average of O of 1, so it will take O of n into 32 in worst case, n into 30. Okay, so also I'm attaching this trie solution, so if you find any doubts you can reach out to me in the comment section of the video, and thank you for watching this video, and don't forget to subscribe.